Hey, welcome back to Data-Driven Engineering. My name is John Hedengren, and I'm going to go through some video processing today. How do we deal with video? And this is part of our series for Data-Driven Engineering, and this is data access, one of the modules. We just finished audio, and now we're going to cover some of the video. And so we'll come to this address right here. I'll put this in the description of the video so you can have the link there. You'll come here to the Python video here on the left. There you can see the GitHub link, and then when it says raw, go save link as, and you can get the Python notebook, or you can run this as well through Google Colab, everything through a web browser. So we're going to work on processing video now as a source of information for data-driven engineering. I have the notebook here, and let's first of all just install OpenCV. You'll need to pip install OpenCV for Python. If that's already there, then you can comment it out, or if you run it and it's there, then you'll see that it's going to say that the requirement is already satisfied. If it installed, then go ahead and just go to kernel and then restart your kernel, and that will let you use the package. Okay, and then comment that out so it doesn't need to run again. Okay, let's go ahead and import some libraries for video processing now. We want to first of all import NumPy and matplotlib and then CV2. That's the OpenCV package. OpenCV is also in other environments as well, and Python is just one of the interfaces to OpenCV. Okay, so CV2, we're going to download a video file now. We're going to do URL lib request. We'll get runner.mp4, and there's the URL plus the runner.mp4. We'll retrieve that, and that will save it to our run location. In this case, it's on my desktop. All right, so here we can see the runner.mp4, and I'll just go ahead and open that up. Here's the video file. It's only, I think about 0.75 seconds. Okay, so there it is. We want to view the video maybe in our browser right here. So we're going to do from ipython.display, import video, and we'll have a width of 550 pixels. All right, here we can view it here from the Jupyter Notebook as well. Okay, let's go ahead and import the video file so we can start working with it. We're going to use cv2.videocaptureF. Okay, now if you put a 0 in there, it's going to grab the video from your web camera. And if you have two web cameras, you can do 0, 1 to switch between those two, or you can do the file name. So this is runner.mp4. It's going to be this file right here. And we're just going to import that. And then let's go and look at the width. We're going to look at the capture property frame width, and then also the frame height to see its dimensions. And then we'll release the video and then print those dimensions. So we see it's 1920 by 1080. It's a fairly standard size for high definition video. Now let's go ahead and read the frames. Now we don't normally do this in normal scripts where we read all the frames into memory. We typically just read one frame at a time, process it, and then write it back out. So it doesn't keep all of that information in RAM memory. But we're just going to do this just for this exercise because we want to show a couple things about how we process videos. Okay, so here I have IMG. Those are going to be my images. And then while this video is opened, we're going to read a frame, and it'll report success and also the image. If it's successful in reading a next image, then we're going to append that to IMG. So it's a list of frames that we're going to create. Else, we'll go ahead and break this loop, and then we'll release the video from being opened. And so let's go ahead and look at the number of frames that we read in, and that was equal to 22. Now at 30 frames per second, that means that we went for 22 divided by 30 in terms of number of seconds. Let's convert BGR, blue, green, red, that is common in these the OpenCV format to RGB format that we're going to use for some of the processing. Okay, so for every image that we have in our list, all 22 of those, we're going to cycle through and we're going to convert the color, okay, of that image. We're going to convert it from BGR to RGB. So we're just going to switch the first and the last numbers that are 0 to 255 for color from the blue and the red. Okay, so the green stays in its same position. All right, so let's go ahead and do that, and now display the first 9 frames. Okay, I'm just going to go through the first 9, and with matplotlib, I'll use image show, and then look at a tight layout there. Okay, and this is just going to show the first 9 frames. And matplotlib is particularly helpful because it will show you the pixel location. So 1080 by 1920 for each of those. So there's our first frame, second frame, third frame, fourth, fifth, sixth, seventh, eighth, ninth. Okay, and there are a total of 22 if you wanted to display all of those. Now, let's say I wanted to convert it back to BGR. I'm just going to run this one again and then plot it. Now you're going to see it's going to be kind of opposite in terms of the coloration, and so I'll switch it back again. I'll switch those 2 back, and if I run this one, then it's going to show up in kind of the natural color that we're used to seeing. All right, let's go ahead and do something with these images now. We want to use media pipe, and I'll show you a little bit about this. This is if you just search for media pipe, all right, this is a package that's put out, it's based on TensorFlow for some deep learning of pose. We're going to use the pose version of this, and this is one where we're going to be able to estimate these 33 different positions on the body from the video image. And there's a number of options here that we're going to be looking at, but basically it's just going to be a very easy way to use one of these pre-trained machine learned models so that we can train and track the pose of an individual, in this case the runner, in the frame. So it can only do one person at a time, okay? And there's some other things it shows you, just some templates here for accessing it in Python, or if you want to get JavaScript or others, you can access that. Okay, so we want to go back to our, back to Git pose with deep learning. So the first thing we need to do is pip install media pipe. And so if you run that, you may need to go to kernel and restart if you don't already have it installed. Okay, and once that's installed, then you're going to need to go back and rerun the cells up above, and then we can start using this. Okay, you'll import pandas, media pipe, and we're going to get MP, so media pipe solutions drawing styles, and media pipe solutions drawing utilities, and we'll get pose as well. So we're just shortening some of these names. All right, so do some imports. All right, so it looks like there's a warning there. I'm going to ignore that one. I think it's still going to run. Okay, we'll store the results in a data frame. All right, I'm going to get the left shoulder. And this is the X, Y, Z, and then the visibility for each of these. Okay, for the hip, left hip, X, Y, and Z, and also the visibility. So it's trying to estimate in 3 dimensions from a 2-dimensional image the location of these 33 points. And I'll get the left knee as well. All right, I'll save that as a blank data frame. And then now I'm going to call my pose, my media pipe pose, and I'll have minimum detection confidence 0.2. Static image mode is false. I'm going to be processing a video. Model complexity, I'll have 2. Smooth landmarks, true. Enable segmentation is false. Smooth segmentation is false. Minimum tracking confidence 0.2 as pose. Okay, so I've created this. Now I'm going to go through each of my images, and I'm going to convert IM2, okay, back to BGR, just to be able to process this. And then I have results equals pose, and I'm going to process IM2. So it does need it in the blue, green, red format. This is where I perform the detection of those 33 points. Okay, and so if I do not have pose landmarks, then I'll go ahead and continue on this loop. But if I do, I'm going to draw the landmarks on the frame. So I'm going to use this MediaPipe drawing utility to draw my landmarks, and I'll do it with IM2. And I'll create the connections as well. And then there's just some other options for landmark drawing specifications. Okay, then I'll store my image, IM2, back in IMG. Now I'll store the values in a data frame. All right, now the row, I'll grab the row number, and then I have my landmarks. Okay, so I've just had to go into the documentation and look for how it actually stored those, because I want to extract those and put them into a CSV file, a text file. So number 11, 23, and 25. So if I go here to the web page for this, I just grabbed the marker. So I had 11, okay, and then I had left hip, okay, that's 23, okay, and left knee is 25. But you can pick out any number of these. You know, if you want the left pinky, the right pinky, the nose, the left eye inner, etc. Okay, so sometimes they change these back. A while back there were only 32 points, and then they went to 33. So make sure you have the right documentation for the current package, or the numbering may be off. Okay, so there I have 11, 23, and 25. And then I'm just going to extend my row with X, Y, Z, and visibility. All right, and then I'll store this in my data frame for location I, and then I'll send it to a CSV file. Let's go ahead and plot just one of the images. Now here, instead of using the RGB to BGR, I just swap these two. Okay, so the blue goes over here to the third, and the red goes over here to the first. Okay, so I just swap the order of the pixels. And this is our tight layout again. Okay, so let's see if I have an error here. Oh, this is not found. Okay, let's see what happened here with the download model to MediaPipe. Okay, I might need to run this again. Let me just go ahead and do kernel restart and run all, and then I will see if I can get to that point. Okay, it looks like I have an error here that I need to go figure out how to correct. So it looks like there is an error in downloading the model, okay, from this address, right, or downloading it to this location. So I'm not sure. It looks like there's some kind of an HTTP error there. Okay, it wasn't found when it tried to run it. I guess there's a redirect handler. So there's something going on here with downloading that pre-trained model. So let's just switch over to Google Colab for now. I've never had that issue before, but you know, this is the first time it has happened. So let's go ahead and just run. I'm just going to go run all here, and we'll get back down to that place. Now there'll probably be an error that MediaPipe is not yet installed. So I'm going to uncomment this, okay, because it's probably, let's see if it has that error. Oh, it made it. Okay, so if you have that error, then just uninstall that, run that cell. You don't typically have to restart the kernel in Google Colab. Okay, so here you can see the one frame, the first frame, and identified these 33 points on this runner. Now let's go ahead and modify the frames to add some text. Now I'm just going to show this to you. It's already in here, but I'm going to add this 0.2. Okay, so this is our this is one of the following frames. This is the 6th frame in, or 7th, I guess. And we're just going to put, we're going to use OpenCV to put some text onto this. So here's some black text. I'm going to make those numbers just a little bit bigger. I'm going to give it, font size of 20 there in terms of the thickness, and then of 10. I'll also do white underneath it. And that works well if you have a dark or light background. You outline the numbers with a darker, font, and then the inner is going to be a light one. So it's going to show well if you have a black or a white background. Okay, so I have these two lines where I put the time. Okay, I converted that time to this particular format so we can see like a timer for the runner who is running on this video. And then let's go and just modify the frames. We're going to scale it to 0.5, and we're going to use a CV2.resize. And we'll resize that by 0.5. So the 1080 by 1920, that'll automatically be half that size when it finishes here. If I run this again, it's going to scale it down by another 0.5. So you only want to run that once. Now let's look at the new dimensions here. Oh, I guess I did run it again. Now it's 270 by 480. I'm going to go ahead and just run all again because it came down through here once already, and it scaled it down to a quarter of the size. So I didn't want that. I only wanted half the size. Okay, so there are the new dimensions, 540 by 960. That's half of 1080 by 1920. All right, and then let's go ahead and display the resized frames. So we can see them here, and you can see with Matplotlib, the upper left-hand corner, that's 0, 0. You're used to having 0, 0 be down here at the bottom left, but for images, it starts at the upper left. Okay, and then you get additional pixels this way and additional pixels this way. So here's the timing for the first 9 images. And now we want to export this video file. And we have a couple options here. We have AVI, MP4, and then WebM. Okay, so this is a slower writing, smaller file. This is more compatible with browsers. Okay, so sometimes this one's not compatible with some browsers. This is very fast at writing, but it's a much larger file. So let's go with the WebM format for now. And we are going to use this output OpenCV writer. And I'm going to slow the frames down as well. Instead of 30 frames per second, I'm going to go to 5 frames per second. So it's going to slow down the video a little bit. All right, and then I'm going to go through the images and write those out with the video writer and then release the video. Okay, now let's go ahead and just display this. This one doesn't sometimes show the video here in the Google Colab, but if we come here, you're going to be able to see runner.webm. You can download it, and here is the final video file. Let's see if we can just play this. Okay, so there you can see the runner with the 33 points that are placed to recognize where they are, and then also the timer. All right, so now we have a knowledge check. We want to calculate the distance from the camera and an estimate of the velocity the runner is moving away. Use the distance between the left shoulder and left hip as a scale to determine the distance. Use how the scale changes with time to determine runner velocity. Display the distance and velocity of the video frames similar to the timer and numbers. All right, so if we come back to the web page as well, I'm just going to come here to video, and then scroll all the way down. It gives a little bit more detail on some of the calculations. Okay, the distance from the left shoulder to the left hip, okay, that's going to be the x of the shoulder, x of the hip squared, plus y of the shoulder minus y of the hip squared, plus z of the shoulder, z of the hip squared. And then you take the square root of that, and that'll get the magnitude of the distance. All right, and then we know that the video is 30 frames per second, so each frame is about 0.0333 seconds, and we can get the velocity approximation, at least from the change in distance. Okay, that's not the change in change in distance that the runner is away versus time. So I guess I should have a different D here. I'll change that later. This is the distance the runner is away, and this is the distance from the left shoulder to the left hip. Okay, so might need to use a filter to avoid large changes in velocity. We'll display the distance of velocity on the video frames similar to the timer numbers. So let's just come back here to our video right here. We're going to reuse a lot of the same things that we had before for the other parts of this video. But let's go ahead and just read in the pose data. Okay, so that one is this file.csv. Okay, so if I say look at the head of that, then I'm going to see, let me bring this back over. There I see the frame, the left shoulder, here's the left hip, and the left knee. So all of those were stored when it went through. Now let's get the 3D distance from the left shoulder to the left hip. So I'll insert a code cell. And so here is my distance calculation. And let's just look at the head of this again, and there is my distance that it is between those two parts on their body. All right, and let's insert a new cell as well. So now let's just calculate the distance that runner is away. And I'm just going to use something extremely simple here. There's some changing angles and other things, but I'm just going to say it's 1 divided by that characteristic distance from the image search. Okay, and let's insert another code cell, and then we also need the time. All right, so there's our time. It's 30 frames per second, and let's go with okay, let's get our velocity calculation as well. Okay, I'm just going to copy some of these in. You can see the code, but I've got essentially, when I come through it, I've got my distance minus my distance previous divided by time. So that's my instantaneous velocity right here. And then if I'm on my very first frame, so I go from 1 to 22, if I'm on my very first frame, I just want to initialize all of those to be equal to VI. And then the next time through, I'm going to have this filter set up with alpha. So I'm only going to accept 10% of the velocity change just to be able to smooth it out a little bit, because that distance measurement, especially as the runner gets further away, is not going to be incredibly accurate. There's going to be a lot of jumps, and small jumps in that distance between the left shoulder and the left hip are going to create very large velocity changes. All right, so let's go and run this one. And okay, so we've got our velocity, and I'll insert another code cell. So now let's add distance and velocity to the frames. All right, so I've put the distance that they are away, 4.5 meters and 6.8 meters per second, and I've placed those. I've placed these the strings right here using the black, and then the smaller font for the white right in front of it, and then we show the image. Okay, this is just the 7th frame right here. All right, and then I'll insert another code cell. Now we'll create a new video with this. All right, and if you are on your local your local notebook, you can show video and this will actually show up. But if not, and you're here in Google Colab, then we're going to come here and just download this one, and then we'll be able to see it here on our desktop that it downloaded it, and you can see the distance they are away and their approximate speed they are running. So not incredibly accurate here, but it's a good start. It's we have some kind of an approximation here. We've been able to see how to do video processing, take each of the images and be able to do some pose estimation with deep learning using a pre-trained TensorFlow model, and then put some of the results onto the image with OpenCV. All right, so what's coming up next? So we have this module right here on video processing, and that's an excellent way, a source of information that we can use for data engineering. The next one we're going to take a look at is databases and how to connect, update, select, fetch, these different database operations to be able to access data and store it into a database.